Okay. In the following experiment, a coffee cup container containing 100 milliliters of water is used. The initial temperature of the calorimeter is 23 degrees Celsius. If 9.90 grams of calcium chloride is added to the calorimeter, what will the final temperature of the solution in the calorimeter be? The heat of solution of calcium chloride is 82.8 kilojoules per mole. So first of all, let's write our first law of thermodynamics statement. The sum of the energies of the universe has to be equal to 0. We've got two processes going on. We've got a heat of solution, and then we have, for the actual reaction, so to speak, and then we have the heating of the water, just to make things a little bit clear there. We know that since this is a heating process, it's going to be the mass of the solution times the specific heat of the solution times the change in temperature. And here's where things get a little bit tricky. What is the heat of solution? Well, you have 100 milliliters of water in your solution, but what else do you have? You have 9.90 grams of calcium chloride as well. So your mass of solution here is actually going to be equal to 109.90 grams. You also know that the specific heat of water is 4.184 joules per gram per Kelvin. And I like solving for my delta T as a variable and then worrying about that random 23 later. So we're going to add that to our heat of solution, and this heat of solution is the product of our reaction here. And it's going to be equal to the number of moles of calcium chloride times the heat of solution per mole. We know that right off the bat is a negative 82.8 kilojoules per mole. Now we just need a number of moles. We can do that with no problem. We've got 9.90 calcium chloride times 1 mole calcium chloride is equal to, so we're going to need to run to our periodic chart to actually calculate that molar mass of calcium chloride. Shame on me. My periodic table is so completely buried on my desk. My nice laminated one ran off, and I'm too cheap to actually pay for one. I got mine for free years ago. At any rate, enough of my tale of woe. Alright. I'm going to actually erase this because that got really messy there. I'm going to use the hand tool for the first time here. And let's draw this out here. I'm calculating my moles of calcium chloride. And my moles of calcium chloride is going to be equal to 9.90 grams of calcium chloride times 1 mole of calcium chloride over, and let's see, calcium chloride is 40.078 plus 2 times 35.4527, 110.9834 grams of calcium chloride. Multiply everything on top, divide through by everything on the bottom. So that gives me a number of moles of calcium chloride of 0.0892 sub 0. So I'm going to place that in for my number of moles in my equation. So let's bring that back up again. So now we can begin our plugging and our chugging. So that gives us a negative 7.3859 kilojoules plus, and I'm going to multiply my 109 and my 44.18 here. 109.9 times 4.184. That gives me 459.822 joules per Kelvin. Or actually I can do per degree Celsius there if I want to, just to make our life easier later on, because the size of a degree Celsius is the same as a Kelvin. Times, of course, our variable delta T. Okay. We have joules and kilojoules. All of this has to equal 0. We have two different units. We have kilojoules and joules. I'm going to go ahead and convert my joules to kilojoules right off the bat here just to make life simpler. One kilojoule is 10 to the third joules. So that gives me a negative 7.3859 kilojoules plus 0.459 822 kilojoules per degree Celsius times our delta T. Now I want to get my variable isolated, so I'm going to move this right here to the other side of my equation by adding 7.3859 kilojoules to both sides. So that gives me 7.3859 kilojoules equals 0.45982 kilojoules per degree Celsius times my delta T. Now to solve for delta T, I'm going to divide both sides by my 7.3859 divided by 0.45982 kilojoules divided by kilojoules per degree Celsius. So that gives me, whoops, a change in temperature of 16.06 degrees Celsius, and like Bon Jovi says now, we're halfway there. That's our change in temperature. And remember, change in temperature equals temperature final minus temperature initial. Our initial temperature was 23 degrees Celsius equals 16.06 degrees Celsius. Move your solve for TF by adding 23 to both sides. That gives you 39.1 degrees Celsius. Booyah!